Everyone here knows that the alert signal, a steady blast of from 3 to 5 minutes duration, means to take action as directed by the local government.
In the years following World War II, faced with the possibility of destruction on a massive scale, the U.S. government and its civil defense agencies needed a way to alert the American public if there was ever a danger of real attack. One of the staples of this system was the air raid siren, like this one here in Seattle. Like many others, this one was tested weekly to make sure that it would go off in the case of an actual emergency. If you're old enough, you might even remember those tests. Or you might remember hoping that that day would never really come. But what you might not know is the system that was behind it all, the thing that actually made the sirens work. Starting in the early 1950s, AT&T had the idea that their vast interconnected network could be used to warn people of their impending doom should the need arise. The system included these weird dials, these boxes with numbers on them, and of course, the air raid sirens themselves. And it was called the Civil Air Raid Warning System, or Civil Air Defense Warning System, depending on who you ask. Some of the old guys at the museum called it the car wash, and that's what I happen to call it. So if you hear me use that term in this video, just know that I mean CARW. The Air Raid Warning System was designed to be hierarchical. At the top was the ADCC, or Air Defense Control Centers. They were responsible for combining data from a number of radar systems like the DEW line across the US and Canada. When a possible threat was detected, information was conveyed over communication networks such as White Alice to the National Defense Headquarters, and from there, a decision could be made to transmit warnings to the affected areas. Each populated area had a key point, such as a police station, fire station, or other building which could be occupied 24 hours a day. These locations were furnished with a special dial that was used to sound various alerts. So when a key point received an attack warning, they'd use the dial to disseminate the warning out to the general public.
When a warning is received by the local government through the attack warning system, sirens and bell and lights throughout the community are activated simultaneously.
The dial is pretty cool, and we're lucky to have it. There were relatively few of them ever made, and most of them were discarded in the 1980s when these systems were decommissioned. In fact, the whole reason I decided to get this equipment running was because we finally got a dial from some friends of ours. Right away, you can probably see that it looks a little bit different from a normal telephone dial. For one thing, it's only got 5 holes, and instead of numbers, there's color markings. As an aside, in all the videos and photos I've seen, there were multiple styles of markings on these dials, but they were all used in the same basic way. When an alert came into a control point, the person in charge would lift the cover and then dial the desired color twice. Dialing twice helped to ensure that the warnings were not distributed accidentally. If a user dialed 2 different colors or an invalid code, no warning would be sent out, and if it was desired to stop the warning signal, the user dialed stop just once. Now, there are 2 types of warning apparatus that these dials can control, and it's really up to the municipality how they're used. The 2 types exist because, well, sometimes you want to warn the general public and sometimes you don't. If you want to warn the public of danger, you've got the city air raid sirens, like the ones we mentioned at the beginning. Customers could actually choose either to manually engage their sirens or have the system do it for them automatically. If they wish to have their sirens operated by the CARW system, as most did, the telephone company installed a relay at their premises that would operate over the telephone network and close a local circuit to start the siren. The second type of alert apparatus was this wall-mounted box, which they referred to as a bells and lights station. These were distributed to factories, schools, hospitals, and anywhere else that needed to coordinate the movement of many people during emergencies. The box is
basically a regular telephone subset with a ringer inside, except that it also has 4 lights at the top. Each lamp is associated with a particular ringing cadence and has a particular meaning. These meanings could be somewhat variable, so I'll just cover the most common usage here. Each code is sent by dialing a color twice. Again, this was a safety measure, since they didn't want people accidentally setting off air raid alarms. So if we dial yellow, yellow, we'll transmit a test signal. In the early 1960s in Seattle, this was done every day at 10 a.m. Test signals rang the bells and lights, but the air raid sirens weren't activated. If the customer didn't hear the bells at the appropriate time, they were supposed to inform the phone company so that their devices could be serviced. The blue-blue code was a generic alert signal and was sent by dialing 66, or blue-blue. When in blue status, the public siren sounded a steady alert tone, and each bell and light station flashed an alert cadence. This meant that the recipients should take steps to secure their facilities, but that an attack was not yet imminent. The real serious code was red, which meant take cover. This also sounded both the sirens and the bell and light stations. The sirens in this case were blasting the familiar rising and falling tone that's associated with a nuclear attack. Finally, there was white, or the 00 signal, which meant listen to radio. This was not sounded on public sirens, but the bell and light stations had a continuous 16-second on and 16-second off ring pattern. The system is configured to reject any dialed digits outside of the acceptable range. So if I somehow manage to dial 55, an alarm will be sounded at the central office. Also, dialing any single digit without the same digit following it will cause an alarm too. So I can't just dial 84 or 6 and nothing else. That'll cause an alarm. The one exception to this is by dialing 9, the switchman could test the operation of the digit register circuitry in the CO without activating any parts of the warning system. This may sound unreasonable, like why sound an alarm for literally anything except the valid code? Well, the system could be critical to saving lives in the event of a catastrophe, so anything that wasn't an acceptable code needed to be investigated for possible equipment failure or tampering. To mitigate the possibility of someone playing with the dial, the covers were actually locked by this lock here. They were not intended to prevent picking attacks, but to resist someone casually playing with it. If a legitimate alert needed to be sent out and the key was lost, users were instructed to pull the cover open with force, overriding the lock. So in an emergency, I could grab the handle and yank the cover to expose the dial to send an alert signal. Finally, alarms will sound if any dial is disconnected from the network. This is implemented in a dead simple fashion. Each dial is constantly connected to the digit receiving circuit, and if any of the dial circuits lose electrical continuity for any reason, even momentarily, the system will go into alarm. These bell and light stations are pretty interesting. First, like I mentioned earlier, they were mostly just regular telephone subsets, which included a bell and all the other electrical gizmos needed to make your phone work. Instead of reinventing the wheel, the phone company used parts that they already had lying around by the millions. But they also added this row of lamps across the top. And as some of you may have already suspected, the lamps aren't just ordinary light bulbs. So let's take a look inside. What I've been calling lamps here are actually tubes. And the obvious question is, why would they just use weird tubes instead of ordinary light bulbs? And as it happens, this answer will lead us directly into how these boxes work. You see, they needed to be able to send 4 distinct signals over a standard 2-wire telephone circuit. And remember, this system does not involve computers or data processing of any kind. It's just standard analog electrical signals. Each of the 4 warnings included a distinctive bell cadence, and a particular lamp would light. The bell ringing cadence was relatively easy to do, since the central office could just open and close the ringing circuit of the bells in time with whatever pattern they wanted to send out. And surprise, surprise, that's exactly how they accomplished that. But lighting any one of 4 lamps with only 2 wires is a little bit more difficult. The proper name for these lights was the 359A electron tube, and as the book says, it was a 3-electrode cold cathode tube for use primarily as a relay in communication circuits. So the original intended purpose of this tube was as a relay. That's so neat. The description goes on to say, it is also suitable for use in control circuits, such as in triggering, counting, or switching apparatus. And at the very end, it says, and as a visual indicator.
The fact that they glow orange when they're in the on state is just a side effect of how they work. And these particular tubes were just the right size and produced just enough light that they could also be used as indicator lamps that have an extra trick. And that's pretty cool. Here's a diagram of a cold cathode trigger tube in the circuit. When you apply enough positive DC voltage to the trigger contact, a small spark will jump to it from the cathode. That ionizes some of the neon gas in the tube. In other words, it rips loose some of the electrons from the neon atoms. Once that neon is ionized, it's able to conduct electricity between the anode and the cathode, which then ionizes the rest of the gas, and now the relay contacts are effectively closed. The current flow also makes the light glow as a side effect. The important bit for us is that these tubes are sensitive to the polarity of the trigger voltage and will only turn on when the trigger is made positive relative to the cathode. So, to light the correct lamp, they add a 48-volt DC potential on top of the AC ringing voltage and connect 2 of the tubes to it in opposite directions. Only the tube whose trigger is made positive will turn on, so by changing the polarity of the added DC, they can light one tube or the other. Okay, what about the other 2 tubes? Well, that part's pretty simple. One pair is connected between the tip wire and a local ground, and the others are connected between a ring wire and a local ground. So the combination of positive and negative voltage on either the tip or the ring wire gives us 4 possible ways to light the tubes. They didn't invent this whole idea just for civil defense, by the way. The trick with cold cathode trigger tubes and the tip and the ring wires was also used for one version of the 4-party service to make just one of the 4 telephones of the party line ring. But this reuse in the car wash system is quite clever.
The whole show is controlled by frames like this one in the central office around town. Ours came out of the Lakeview office in Northeast Seattle, and like many things, it was brought here but never hooked up. Earlier this year, I suddenly got interested in it, and I really wanted to get a proper dial to operate it. We were able to trade with another museum for the dial I showed you earlier. Once we had the dial, it finally made sense for me to get the rest of this system back into working order. I started by connecting power to the various circuits. This is historically a very messy area of the museum, and there's big volts all over the place. I'm not sure why the museum founders designed it this way, but everything in this half of the aisle is just a misery factory when it comes to wiring. So you have to be really careful when you go digging around over here. I am so proud that I only got shocked twice while bringing these circuits up. This frame wants the standard minus 48 volt central office battery and also a plus 48 volt supply for lighting 2 of those lamps on the positive rail of the signaling box. The circuit normally called for large dry cell batteries like these to be placed in this box to supply the plus 48. But since I didn't have any of those that worked, I just purchased a 48 volt power supply from my local electronics recycler. It's not pretty, but it works. The frame also has a ringing generator that works independently from the main CO ringing supply. This generator is started and stopped on demand, since it was likely that the circuit would only be used very infrequently. Our particular machine was seemingly cut out of another piece of equipment and then mounted here, and also someone had tried to hook it up earlier, but for some reason they never fully completed the job. With the help of some other volunteers, shout out to Jay and Peter, the circuit was reverse engineered and we discovered the printout of the connector and we were able to get the generator spinning. Once that was accomplished, I was pretty confident that I could get the rest of the frame working. The next part was the dial pulse receiving and control circuit. This was pretty easy, as it just wanted power. Above that was the signal distributing circuit that had been partially taken apart and used for an unrelated purpose. So I put that circuit back together and I made that go too. These large relays here have many sets of contacts on them, and they're what actually distributes the signal and cadence to the customers. The last bit of the puzzle was the repeater circuits down here by the battery box. I had a difficult time finding documentation explaining how and why these were used, and I spent a few days figuring out ways to eliminate them from the frame until I realized that they were integral to the system, and it would actually just be easier if I figured out how to use them properly. So I did that, got the repeater circuits working, got the rest of the wiring hooked up, and I'm pleased to report that the system actually works like it's supposed to now.
As Sarah was working on the technical component of this project, I was reorganizing our library here at the Seattle Museum, which has proved to be a truly incredible collection. I discovered a copy of documentation provided to the King County Office of Emergency Services showing that Pacific Northwest Bell stopped auditing these siren installations sometime in the 1970s, and then had to play catch-up to figure out what sirens were still in service, which had been removed or relocated, and when. Even the routine test records we have in their original hand-signed audit logs from the early 1970s are a far cry from the days of daily duck and cover drills and home bunkers that America's civil defense agencies were conducting at the time of the car wash installation. The records request that I found in the library really helps to explain how the network worked and why those repeaters that Sarah mentioned were important. On this page, we can see a diagram of the wiring network for the air raid siren here in Seattle. The actual dial was down in Renton at the police department, and that sent signals to the Parkway Central Office. Parkway then sent those signals out to the adjacent offices, where they repeated again and again to all of the offices in Seattle. The repeaters that Sarah was talking about are how the warnings are actually sent throughout the city. If the red code is dialed, they provide the signal to the sirens as well, like the yellow Chrysler motor-driven one at the beginning of the video, which is still installed in the Finney Ridge neighborhood. I've made these documents and many others available on archive.org, which I'll have links to in all the usual places a YouTube video has links. So, why did this system become disused? As the nuclear arms race progressed, both the United States and the Soviet Union began developing more advanced rockets to reach outer space and to demonstrate their ability to build effective ballistic missiles. With them, they would be able to deliver increasingly powerful and numerous nuclear warheads anywhere on the globe in much shorter time spans and with much greater lethality than those even imagined in the 1950s. But at the beginning of the Cold War, Bell Labs and Western Electric had both played a significant role in developing technology and training soldiers in field telecommunications for the United States during World War II. They made a transition that many research and manufacturing companies made at this time and began working on government contracts to help build the nation's defense network against the threat of nuclear attack. Bell Telephone's experience before the war with amplifying signals and fundamental scientific research made them a natural fit to develop these technologies in the first place. White Alice and the DEW line, which Sarah mentioned, were two of these projects. White Alice was an Air Force microwave relay communication network designed by Western Electric. It was built to relay communications to regions where traditional telephone service was impractical to install, such as remote locations in Alaska and the Canadian Arctic. White Alice was being constructed to link the new radar system that Bell Labs was designing at the time, the Distant Early Warning, or DEW line. This continent-wide radar line was built to detect incoming Soviet bomber aircraft over the North Pole or the Bering Strait. The theory was that in the event of a first strike by aircraft, White Alice and the DEW line would provide America's civil defense agencies with enough early warning to sound their air raid sirens and evacuate the population from the city center or other target areas. As the Cold War grew on, and missiles and submarines developed, this idea became increasingly impractical, and civil defense policy was eventually replaced with the more familiar duck and cover drills and paranoia over home bunkers. Both White Alice and the DEW line were actually the third and furthest north systems to be installed, and the engineering effort the Bell system put into their construction and the technology behind them was enormous. This board above me shows some of the microwave relay networks that were later constructed here in the Pacific Northwest, once the Bell system was able to make the technology developed for White Alice a cost-effective and comparably miniaturized communication method for relaying consumer telephone calls. Some of the equipment here in our museum is from Alaska, where these defense networks were originally installed. And we even have some original photographs of the DEW line and White Alice provided to us by the many employees of the Bell system who retired from their work in Alaska to down here in Seattle. This microwave technology later proved to be vital to scaling AT&T's long lines communication network as America's telephone-using population grew. And if you've ever seen these horns on a tall building in your city or a tower on a mountain peak, now you know what they are. I mention this because the Bell system was very proud of its involvement in these projects. As part of its marketing to stave off eventual divestiture, the Bell system used projects like White Alice, the DEW line, and many others as proof of its innovations in communications technology. In addition to the film reels we've shown clips of throughout this video, the Bell system produced these booklets, which were freely distributed to employees of Pacific Northwest Bell, intended to provide proof of their innovation, patriotism, and cost savings for the consumer. Back in the world of the military-industrial complex, however, the Bell system would even help design, build, and operate an entirely separate telephone network called Autobahn. This card-dialed telephone we have, and this classified book of telephone numbers, are very rare artifacts from this unique network, which connected air defense command centers, military bases, and the president with a prioritized telephone system that met the military's hardened specifications. These red numbers next to the traditional dial pad designate the call's importance and would prioritize them over other callers if necessary. But these systems weren't to last. As nuclear arms proliferated and a first strike scenario by aircraft was replaced with the threat of an unsurvivable nuclear attack by ICBM, the DEW line's radar became an ineffective warning system, and it would have to be upgraded. The Civil Defense Agency's air raid warning system, however, couldn't really update its effectiveness for this new threat model, and as mentioned earlier, it fell into disuse within a few decades. At the same time as the Civil Air Raid Warning System was being disconnected, White Alice was being replaced by satellite communications. Funnily enough, the Telstar satellite, which was built by Bell Labs and launched by NASA a decade earlier in order to relay transatlantic radio, TV, and telephone communications, was destroyed by high-altitude nuclear test Starfish Prime just 7 months after it was launched. I'm really happy that we're now able to show off this terrifying and paranoid time in US history. One of the things I love about the museum is that there's so much cool stuff waiting around for years to be discovered by volunteers like us. Hey, thanks for watching. We'd like to give an especially big thank you to the JKL Museum of Telephony, who were kind enough to donate the Civil Air Raid Warning dial that you saw upstairs. It's a really great addition to our collection, and we're really thankful. Also, we have t-shirts like this one available on cottonbureau.com if you search for Connections Museum, and we hope you really like them. Thanks!